this case, what is our x variable? The x, or the dependent variable, independent variable, I'm sorry. The x, or the independent variable is what? Number of pages. Okay, so the number of pages, that's just going to be a count. Maybe 600 pages, or maybe 350 pages, this textbook. Okay? The y, or the response, or the dependent variable, that would be the thickness. Would we have a positive relationship, negative relationship, or no relationship? A positive relationship. Okay? Books with lots of pages tend to be thicker. Books with fewer pages, so low x value, tend to be thinner, low y value. So we have a positive relationship. Is that okay with everyone? Are there any questions? Okay. All right, there's another aspect when describing a relationship. Okay, and that is the strength of a relationship. Okay. The strength of a relationship is essentially another way of asking, how good is your prediction going to be? Okay? So if trying to think of a good example. Strength of, yeah. How good is your prediction? Okay. So if we're looking at the height of a student, okay, in elementary school, okay, there's all sorts of things that play into how tall the student is. Okay? Nutrition, genetics, gender, all of these things play into how tall the student ends up being. Okay? So the question is, how good of a prediction will you get using the student's age all by itself? Okay? And if you think your predictions are going to be pretty good, we would say you have a strong relationship. If the predictions are not going to be very good, you have a weak relationship. So good predictions, meaning your predictions and the actual values are only off by a little bit. You have a strong relationship, okay? So good predictions indicate a strong relationship. That means your there's not much difference between the actual values and what you predicted, okay? if your predictions are inaccurate, okay? So inaccurate predictions. So not wrong, but maybe there's a whole lot going on. Inaccurate predictions might indicate a weaker relationship. Yes?
The strength of your relationship is based on how accurate your predictions are?
Well, that's one aspect of it, okay? But yes, essentially, okay? Another way to look at it is how much scatter is there in the scatter plot. Okay, so let me just try to think of a couple examples here. So if your data set looks like this, okay, so let's say we have two data sets, okay, numeric variables, positive relationship. In this case, here we have a strong relationship, okay? There's a little scatter, we can make good predictions, strong relationship. Good predictions, and little scatter. Okay, over here we have a weaker relationship. Our prediction's not so good. And lots of scatter. So for example, a strong relationship, maybe this could be how much TV you watch, let's say just on one of the main networks, so ABC, NBC, CBS, or Fox. Okay, so one of the main broadcast networks, how many hours of TV you watch, and how many minutes of commercials you watch. Okay? You're going to have a very strong relationship. Okay? Pretty much, it's about, for every hour, you're going to watch approximately 18 minutes of commercials. Okay? Yes. Varying from program to program, it might be a little bit more than 18 minutes, a little bit less than 18 minutes. But if you watch 5 hours of TV, you can expect to watch around 5 times 18 minutes of commercials, so about 90 minutes of commercials, okay, in 5 hours of TV. But yeah, is it possible that you watch a little more, a little bit less? Sure, but it's going to be very close to that number. If you watch 5 hours of TV, we would predict 90 minutes of commercials. Maybe you ended up watching 87 minutes of commercials, okay? Who knows? Okay, so we could have hours of TV watched. Minutes of commercials watched. This is broadcast TV. So in there, if you tell me you watched this many hours of TV, and we were to take a stopwatch and measure how many minutes or commercials, we would have a very good idea, okay? But yeah, it varies because sports programs, there's actually a bit more variation in sports programs. There's different rules about how many commercials you can stick in there and things like that, okay? But overall, during prime time, it's going to kind of follow this rule. All right, weak relationships. On the other hand, yeah, maybe this would be something like someone's income and the value of their house. Okay? So annual income and value of house. So in general, we would see a positive relationship where people who make more money tend to own houses that are worth more, but you're going to have a wide range, okay? So if you look at people who make, let's say, $100,000 per year, some of those people will own houses that are worth $300,000 or $200,000 or something, and some of those people will own houses that are worth, $700,000 or something if they make $100,000 a year. Or maybe even more or whatever, okay? You're going to see quite a wide range. So just knowing someone's income alone will not give you a huge, the most accurate prediction of how much someone's house is worth, okay? If someone makes $50,000 per year, how much is their house going to be worth? It's hard to predict. You can kind of get an idea, but the answers are going to vary widely. So here we've got a strong relationship and a weaker relationship. Is that okay? Okay. So far when we're describing a relationship, we want to talk about the direction, whether it's a positive relationship or negative relationship. We want to talk about the strength, whether it's strong or weak, or maybe something in between. And the last thing that we want to talk about is whether the relationship is linear or nonlinear. Okay, all of the examples we've used so far have pretty much been linear relationships. And a linear relationship just means a straight line can summarize the relationship. Okay. Means nonlinear would mean that a straight line cannot summarize the relationship. relationships. Okay, so even with some scatter, overall seems to fit a straight line. Okay. Nonlinear, maybe it goes like this. So this part looks linear, but then if you look at the overall data set, it seems to level out. Okay? So if you were to divide it and just look over here, then yeah, you could say it's linear. But if we look at the entire data set, it's not linear. Okay? Straight line does not fit the data. Okay. Let's take a 10-minute break. We'll come back at 8:55.